Assalamu alaikum. I'm Rida Khurshid, IT 1810168 Our topic is an intelligent Bangla conversational agent, TUNI. These are our contents, which will be presented by me and my fellow teammates. This research paper represents a method of a man machine communication system named TUNI, where TUNI acts like a psychologist and continuously asks questions based on the response of the user. A conversational agent is a machine that allows you to communicate with it using natural language such as English or Bangla. Since the first natural language conversation program, ELISA, other natural language conversational system in the English language have been created in various situations. However, there is no noteworthy study or research for a man-machine communication system in Bangla. Bangla language has more complications than any other language since its pattern is not established like those of other languages such as English. The grammatical person affects the suffixes. There is also separate kind of second person that changes the suffix. As a result, the straightforward technique will not be enough for Bangla agent who converses. In this paper, a corpus-based method is proposed which establishes a natural language communication system between man and machine in Bangla language. The machine that have implemented in this paper, Tuni, imitates and responses like a psychologist who can communicate with a user through a comfortable terminal-like interface. Though the machine can mimic like a mock psychologist, the ending capabilities of Tuni Corpus gives the ability to respond in various contexts. Here, also a new strategy was approached that includes pattern matching with a Bangla, parts of speech tagger, and a very basic sentiment analysis. Tuni may provide natural and syntactical valid responses using this method, overcoming the complications. In related works, we have Eliza, which was described by Joseph Weisenberg in January 1966, which was a domain based system that used some semantic rules that simplify matches the keyword from an extensive collection of rules. Then we have Alice, which was invented by Richard Wallace in 1995, is a knowledge based natural language processing system that can communicate with a human by processing the user input using some reasoning heuristically pattern matching rules. Then we have Perry, which was discussed by psychiatrist Kenneth Colby at Stanford University in 1972, which is used to simulate a paranoid schizophrenic patient. Then, lastly, we talked about Dolly, which is a man and machine communication system that was implemented to give replies to a user query in a human manner for education system in the Bengali language. My part ends here. Now, my fellow teammates will continue with the rest. Thank you.
Assalamualaikum. My name is Zarin Tasnim Prami. My ID is 18101589. Now I will be discussing the prerequisite works. Here, the Bangla parts of speech tagging. I will be talking about this one first. So, the noun, pronoun, verb, and adjective are enough for detecting the pattern of a sentence. Additionally, the different form of pronoun and verb are also detected for getting the proper sense of the grammatical person. For adding person-speech tag to each word of a sentence, a dataset is used. The dataset contains a direct mapping of each word with its parts of speech tagging. Now, moving on to suffix processing. In Bangla, suffix plays an important role in detecting the person of the word, as well as suffix tag is also used to modifying a word properly to find out the stem or root. For adding the suffix tags, there is also a dataset. In the dataset, for each same type suffix, there is a corresponding tag. These tags are helpful to detect the input sentence type and to parse the main information. Now, the person mapping. In Bangla, the suffix of verb changes depending on the grammatical person. As an example, the first person word যাচ্ছি will be changed to the third person word যাচ্ছেন. Again, the pronoun also changes depending on the speaker, and there is a different subcategory for each person. The word যাচ্ছেন can be in the form of যাচ্ছো or যাচ্ছিস. So a mechanism is required to handle this type of complex scenario. We introduced a static mapping mechanism that um, applies to the most type of words. A dataset is made which stores the static mapping of the suffix or person change. Now moving on to positive negative mapping. Here a basic sentiment and analyzer that can detect the type of the sentence is introduced so that um, The expressions can be made accordingly. For detecting a sentence contains whether a positive, negative, or negative meaning or none are done by checking the presence of some words. The words are stored in the positive negative data set. So for each data set, for the presence of each word in the data set, there is a corresponding tag that suggests if the word has a positive or a negative meaning. Now, lastly, moving on to the sentence detection pre-processing. Breaking down a complex or a compound sentence is necessary for simplifying the information passing or operation. The sentence can be broken down based on some words or punctuation and its position in the sentence. The words or punctuation are stored in the sentence divider dataset. So, contents of the datasets are comma, tahole, tobuo, je, jokhon, etc. Now, the next slide, the corpus structure. Here, a corpus is a large and a structured set of text. Our corpus contains mainly four pieces of information. They are the keyword, precedence of the keyword, decomposition rules, and reassembly rules. A keyword can be a collection of Bangla words or parts of speech tags. The words are divided by slash. Each keyword contains a precedence value, which is an integer number that determines the importance of the keyword in a sentence. The precedent values are well observed and statically given. Um, each keyword contains a list of decomposition rules. Decomposition rule is made of some criteria, which can be a parts of speech tag or a direct Bangla word or both. Multiple parts of speech tag and a direct word are separated by a slash. For each decomposition rule, there are several reassembly rules. Reassembly rule contains some numerical notation which specifies the index of the first information.
Hello, I'm
So
Rakesh,
thank you
hearing
so
ID
much. This is all
2130116. I'm
from
going
my
to
side.
discuss the methodology and the resulting parts of their paper. So the text is pre-processed first, which makes the input text ready for the next step, finding focus. In the finding focus step, the base word which are represent the matching of the sentence is chosen, and then the matching step, the pre-processed sentence is checked with the all decomposition rule within the focus. So here you can see the diagram they shows, and for the first part, pre-processing, they use five basic operation and performed the pre-processing steps, including removing unnecessary spaces. If the input string contains unnecessary spaces, then all of them are replaced with the single space. And for tokenization part, they tokenize their context into a name list called token list, and no other advanced tokenization process is being used. So in the next part, breaking into sub sentence, they use the focus, which is not only for complex or compound, but context of based on the context they focuses the sentence. A complex or compound sentence has been broken down based on their presence of same word or punctuation which are described as sentence divider dataset. Then the next part, adding tags for each of the token list added with its corresponding part of speech tag using their pure tagging dataset. Then removing unnecessary word. The unnecessary word that doesn't play any role in the meaning of sentence, they remove it from the data input. So next part is the finding focus. Focus is main token, which plays an important role in the meaning of sentence dimension. In their corpus, there is a precedence value for each keyword. The higher is the value, the more importance in a sentence. As per their rule, for each token in the token list, it is searched in the corpus. So if any token isn't found in the exact search, then the stem of the token is searched in the corpus again. If not found, then the part of speech tag of the token is searched within the corpus. If no part of speech tag is found corresponding to the word, then precedence value is set to -1. Then comes the matching part. For each keyword in the corpus, they describe some decomposition rule. The decomposition rule are checked with the token list until one is matched. The decomposition rule is list of some condition which must be met with the token list. For parsing, they use the selected decomposition rule. It is selected for parsing and token list also. A dictionary is used to store the parse token corresponding to the condition of the decomposition rule. So the key of the dictionary is condition and the value is token. And the next step is reassembly rule processing. For this processing, they first select a rule. The rule selection process is circularly selected so that TUNI responds more naturally with the same output. Then placing token is the next rule that contains some numeric notation. The index of the token is parsed dictionary. The notation are replaced by the corresponding token. And then the evaluation function, they modify the evaluation function, parse information as per need. When all the functions are evaluated, then the string is made ready for the output. So the next is the result part. Here you can see they describe that very few conversational agent is available in Bengali. So they compared their system with English conversational agent Elisa. So as we can see there, they showed the comparison in the table. Elisa is said, I can sleep. When the person said, I can sleep from few days, Elisa respond, perhaps you can sleep from few days. And Tuni said, similarly, if the question is, আমি কিছুদিন থেকে ঘুমাতে পারছি না, টুনি কেন আপনি ঘুমাতে পারছেন না? And as we can see that Tuni is replying the same as Elisa, but in Bengali. So we can see that there is a fine conversation between them, which is up to the mark. Now the conclusion part will be discussed by
Assalamu
Rita.
alaikum, it's Rida Khurshid again. So, to conclude, a new method for Bangla sentence processing and meaning parsing is proposed in this paper. The primary complication: of Bangla language, such as diverse person forms, sentence patterns, and suffixes, are solved using this strategy. The approach was developed using a corpus and a variety of datasets. The corpus contains certain terms and rules, and datasets contains tags for or mapping. The dynamic mapping and keywords are also included in this dataset. It allows users to type and converse using TUNI. The parse speech tag, suffix tag, the parse speech neck tag, and resembly rules all affect Tuni's correctness. The more precise the tags and regulations, the more accurate and natural the responses Tuni.